Hello, welcome to Pakibi TV. In this video, I will explain the characteristics of math focusing on universality. Understanding this point will help you understand where to focus when studying math. I will briefly mention related content for a second. Even if you haven't watched the previous videos, it won't be difficult to understand. But I explained the basic content in the previous videos. In this video, what is math? I explained that math is a science that studies patterns or regularities. And in this video, what makes math important? I explained three characteristics of math: universality, necessity, and systematicity. It's a short video, so if you have time, please take a look. One takes about 8 minutes, and the other takes about 5 minutes. Summarizing the above content in a chart, we have the following. The essence of math is the study of patterns, and its characteristics include universality, necessity, and systematicity. This time, I will explain universality. The discussion about universality in math ultimately relates to patterns, and it will directly connect to the discussion about numbers, shapes, functions, etc. Universality? It's a difficult word. Universal concepts is abstract. When we say abstract, it may feel difficult. Generality can also be understood as the same term. However, this term, although it may seem difficult in some ways, the meaning is not so complex. Especially mathematical terms. Once you know them, they are simple and easy. Universality means extracting commonalities from everything. Let's take an example. What is the commonality between wolves, giraffes, elephants, and monkeys? They are all animals. What is the commonality between mugworts, azaleas, forsythias, and oak trees? They are all plants. Then what is the commonality between animals and plants? They are all living things. This process of extracting commonalities is called generalization, abstraction, or universalization. The more generalized, the higher the universality of the concept. The abstractness also increases. So wolves and giraffes are the least universal concepts. Animals and plants come next. And living things are the most universal concept. It's almost like a child's level of thinking. However, just like all mathematical contents, it suddenly becomes difficult. When you learn math, it can be difficult. But in this video, we're trying to solve those problems, so it won't suddenly become so difficult. The concepts of math are all universal. Why does math become difficult? Although the concept of universality is easy, it's because of pushing the concept of universality to the extreme. This causes the following three phenomena in math. The application range of math becomes extremely wide. That's right. Stories about wolves have a narrower application range than stories about biology. Stories about wolves don't apply to elephants, but stories about biology apply not only to elephants, but also to plants and fungi. Second, they use words that seem meaningless. This is why, in many cases, something may be difficult not because it is complex, but because it is incomprehensible. For example, the commutative law of addition, or something more difficult like the cross product of vectors. Oh, tilde, it's not that the words in the book are difficult. It's difficult because you don't know why they're saying those words. Do you know why they talk about the commutative law of addition? I will explain that in the video about functions. It doesn't end here. If meaningless words are intertwined with each other, nothing will be remembered. It becomes incredibly difficult. Take a look at trigonometric addition formulas or differentiation formulas. Various memorization methods are rampant. We will explain these methods in several videos. But anyway, it's difficult to memorize. If you can't memorize it, it won't stay in your head, so it becomes extremely difficult. That's why your complaints about math are justified. Me? I had the same complaints too. I barely got into Seoul National University, and I'm not a genius either. That's why I've been listening to math lectures and studying on my own. Let's not talk about it. When I try to hold back my curses, all that comes out is a bitter smile. First of all, although abstract and difficult, it is understandable why math uses universal concepts. To broaden the scope of mathematical content. That's the reason. To create knowledge that applies to everything in the world. If you're a scholar, you would have such ambitions. Okay, everything is fine. But still, math study is made too difficult. Mathematicians deserve to be cursed. Especially mathematicians who write math textbooks. They are irresponsible to their students. How? First, they teach in the opposite direction of their own understanding. If you read the history of mathematics, almost all mathematicians have thought about specific cases and then generalized them. For example, calculus was developed while measuring the area of a circle, and a general method was established about 1,800 years later. They thought that way, but they wrote the opposite in math textbooks. They wrote the general concept first and then said, "Did you understand? Then apply it here." They learned to walk before they learned to run, but we are told to run before we can walk. Second, mathematicians teach things that took them hundreds of years to develop in one go. The concept of calculus has been developing for 2,000 years, but we have to study it in less than 10 years. Well, we can't help it. We can't study it for 2,000 years, and maybe it's better to learn things backwards when we try to learn a lot of things quickly. But still, there should be enough explanation that this is originally this difficult, so that students can understand it easily, shouldn't there? Third, they write math books as if they knew everything from the beginning. They don't say a word about the thought process behind developing the concept. Why do we care about the commutative law of addition and multiplication? Even a simple explanation related to functions makes it easy to understand. Students can understand it only after learning a lot of other things. It's like knowing the winning numbers for the lottery later and being told to buy the ticket beforehand. You can criticize mathematicians all you want, but is there no solution? As for a realistic solution I have thought of, it seems that the only way is to have someone who is a bit foolish but understands mathematics well and explains it step by step. That's why I created this YouTube channel. So, what are the most universal concepts used in mathematics? In fact, all concepts are extremely universal, but numbers, shapes, and functions are the most basic. And if you think about sets, groups, topology, and isomorphism, you can see that they are regeneralizations of universal concepts, but numbers and shapes are the most fundamental. First, let's look at numbers. You are very familiar with numbers, but they are extremely abstract concepts and are universal because you can count anything with them. Secondly, there are shapes. Points, lines, planes, triangles, rectangles, circles, and so on are examples of shapes. This is also a very abstract and universal concept, as you use these patterns to identify everything that is visible. However, you don't consider numbers and shapes to be difficult concepts. So let's move on to the next concept. The third concept, functions, is a typical example of a difficult but universal and simple concept. What is a function? Addition, multiplication, trigonometric functions, and logarithmic functions are all functions. But there is one difficult part. That is the definition of a function, which is explained as a correspondence relationship in the following figure. This is a function, but this is not a function. You all know this, right? For those who don't know, I will explain it in a separate video about functions. At first glance, it may seem like an explanation for elementary school students, but as everyone knows, this is not a rough explanation for students. It is the exact definition of a function used by modern mathematicians in the most specialized areas. As mentioned earlier, the problem with understanding functions is not that they are complex, but rather that they are so simple that there is nothing to understand. It's too simple. This is where true confusion comes from. This is a characteristic of extremely generalized concepts, just like talking about living things, not just wolves. When explaining living things, it's very vague. In fact, functions are a universal concept at the level of something or existence in common between living and non-living things, not at the level of living things. Anyway, for now, let's just understand that the concept of a function is a generalization of calculations, our thoughts, and all kinds of actions. In other words, a commonality extracted from them. As mentioned before in another video, mathematics is a science that studies patterns or regularities, and all the extremely universal concepts used in mathematics immediately become patterns. It's clear that shapes are patterns, and then why are numbers patterns too? Well, numbers are patterns because they represent quantitative magnitudes, and magnitudes can always be represented by shapes. Actually, there are other ways to explain this, but this is the simplest one. What about functions then? Functions basically connect one pattern to another pattern, and this connection is also a combination, creating a new pattern. Mathematics continues to explore these new patterns that emerge. These patterns are regularities. Thank you for watching. If it was helpful, please hit the like and subscribe buttons once.